Right, last question. So that's nearly across the finishing line. So this one's to do with, yep, all to do with audio. Right, so what we've got, nice wee audio question asking you to calculate the file size. So remember, even just take a pen and highlight it. So 12 second sounds, surround sound, so 6 channels, 2 bytes, 48 kilohertz. Convert this into hertz, convert that into bits. So that's the first thing you want to do. So get them down into the smallest unit, and if this was in minutes, convert it to seconds, and then just times the whole lot together, and you get the answer in bits. Okay. So file size, the duration, which we have, channels, which we have, frequency, you've got that, and the depth. So that's the values that they've given you. Just times them together. That's in bits. And then divide by 8 to get to bytes, 1024 to get to kilobytes, 1024 to get to megabytes, and that should be your answer. Okay. But again, with the sitting audio questions, most of the time they want the file size. Sometimes they'll give you the file size and they'll miss out one of these. Okay. But again, it's just file size, it's just them all multiplied together. Okay. But make sure they're in the smallest unit you can. State a feature sound card required to play this effectively. Now remember, it's surround sound, right? So you need to have everything all synchronised, and that's your digital signal processor, right? So that's part of your sound card. So you've got your analog to digital converter, and digital to analog, and you've got your ESP. Okay. Now a lot of people do like surround sound, so explain why 6 channels allow more realism. Okay, well, it does allow you, it gives you a good impression that if something's moving behind you, or to the right of you, or to the left of you. So they're asking you to explain why. So what I've done, well, from the marking scheme as well, this allows you to have a good impression of actually being in a real life environment. Okay, so for an example, movement, and you can just see, here's a wee example of a car passing. So if you're surround sound, and you get that in the cinema, it might be behind you, so you'll hear the speakers at the back of the theatre playing the sound. Okay. Then saying, what's the term of bit? Bit rate, so it's basically a number of bits that you can transfer in a second. So that's the number of kilobytes, okay, per second. So just the number of bits that can be transferred in 1 second. So that's the bit rate. So if you've got a modem or a router, okay, internet connection, that'll give you the bit rate. So it's the number of bits that you can download or upload per second. Now, what we've got is normalization. So this is when, just draw here, this is when you've got a file and you've got loud bits and you've got quiet bits, okay. So you want to take an average, and you want to take the high amplitude and reduce it to make it quieter, and you want to take the quiet or low amplitude and increase it to make it louder. And that's what normalization does. Unfortunately, you might have a wee bit of background noise in which it increases. Okay, so that's the downside of it. So they're asking there, what's the purpose? Okay, and one limitation. So the purpose is basically this increases amplitude of quiet sounds and decreases amplitude of loud sounds, just to an average essentially. But the disadvantage is quiet noises can get boosted up and will get boosted up, and they become louder. Okay, so if there's a lot of hissing, a lot of interference, it does become louder in that. Okay, because the normalization process can't really distinguish that well between what is sound that you're wanting to keep and just increasing what is actually interference as well. Right, benefit a container file. Well, remember a wee example that we looked at is, see if you want to send a lot of files as an attachment, if you put them up in a zip, right, so it just one file is easier to send, and the others, obviously you need to unzip them, so you need the wee codec to actually, the software to actually unzip it, and it's no different from media files in terms of it is easier just to transfer a single file than many files. That's like you feel, right? So one file to many files, and you basically need to have the software to unpackage them, okay, and just recreate these separate files. So go into your computer, they'll then all get unpackaged, and it might be video clip, might be some audio as well, right? So basically, that's a good thing with container files. You keep it all, as the name suggests, contained in one file. It contains several files, send it across a network, and then you basically unpack it, as it were, okay? So, but you need to have the software to do that. So if I sent somebody a zip file and they didn't have WinZip, they wouldn't be able to open it up. Then we have is G, so you've got digital analog converter, converts from data into analog. Explain why the sound card has analog to digital, or sorry, digital to analog. Well, you're ultimately wanting to be able to play these sounds so the human can hear it. So it allows you to output it to a speaker. So your speaker is going to output is analog. So that's why you're having to actually have a digital to analog converter. Okay. Then they're asking, well, describe two other tasks performed by a DSP. So you're talking about the compress and decompress. You can add effects, you can add delay or reverb onto it. And this kind of links in with the channel, 6 channels, synchronize the channels. So you'll have all these 6 speakers playing their channel at the same time. Okay. You then have wave, okay, and MP3. So they're two compression, obviously. That's lossless and that's lossy. So they're talking about how ADPCM, okay, and this is when if you have an audio file, you're saving each sample. This is okay, and each sample would be saved independently, maybe using 16 bits for that, and 16 bits for that. What this, and that's pulse code modulation. What this alternative is it actually doesn't, it maybe saves every now and then. It's almost like keyframes within MPEG. So it'll save a sample, but then it saves the differences between the samples. Okay, so that's a difference between that sample and that, and it then manages to save it as 4 bits. So you've actually got a quarter of the size of the original file. So basically, differences between samples are stored rather than the actual whole sample. So it will store maybe every 8th sample will be a whole sample, okay? But the ones in between will actually store the differences, so it's very like the MPEG format for video, okay? So it's using 4 bits rather than 16, so it's a quarter the size. And then you're talking about MPEG does it differently, so this doesn't remove any sound, so that's why you can recreate the original file from it. So it's all done mathematically, so lossless is reduced in size mathematically. Lossy is that they actually just butcher the file, remove sounds a human ear can't hear. But what's another one doing it? Well, any sounds that are masked. So any sounds or frequencies that mask other frequencies, well, they're not stored as well. So you'll have a wee graphic in your wee handout. So if a certain frequency will basically drown out another frequency, yeah, it might as well not store the frequency that is getting drowned out. And end of section 3 and enter part C, and it's the end of your question paper. Okay, so good luck.